And so that I don't forget which one's which, I'm just going to write SOHCAHTOA at the top of my paper. Okay, so to find the missing side of a right triangle, you would use the Pythagorean theorem like we were doing yesterday, or, Google Pythagorean triples, if you had two sides that were given to you and you were missing a third side. So this assignment is different because if you look at this, you don't have two side lengths given to you. See how you only have one side length given to you? We have one side length given to us, and then we know that it's a right triangle, and then we have another angle measurement given to us. And at this point, Garrett, let's put the cell phone away. And Whitney, if you could put away your Chromebook for me. Perfect. Okay, so this is going to work in situations where we know we have a right triangle, but we can't possibly use the Pythagorean theorem. If you could use the Pythagorean theorem, I'd probably use that because I've used it for longer. I'm a little bit more comfortable with it. It's faster, that sort of thing. So if I don't have two side lengths, that's when I use SOHCAHTOA. So from now on, if somebody said, how do you find missing information in a right triangle, I would say first Pythagorean theorem, second SOHCAHTOA. That's what I would say if I was looking for information about a right triangle. So when I look at this, I look at the angle that they gave me, which is this one right here. And then from that angle, I have to name the sides that are labeled in the picture. So based on this angle, what is the name of the 5? Adjacent. It is right next to the angle, so that's the adjacent side. And then what's the name of the x side? Is it hypotenuse or is it opposite? It's opposite. How do we know it's not hypotenuse? It's not the longest one. The longest one is across from the right angle, and the right angle is touching this side. So the right angle is across from the hypotenuse. Okay, so we have opposite and adjacent, and which trig function uses opposite and adjacent? TOA, tan. So TOA uses opposite and adjacent, so we're going to say tan of the angle measurement. So we don't have to write theta this time because we actually know what it is. It's not a variable this time, it's an actual number. So tan of the angle measurement equals opposite over adjacent. All right, and then to solve the missing side, we're going to go ahead and get the missing side alone in the problem. So how would we do that? Multiply by 5. So I'm going to do times 5 times 5. So x, the missing side, equals 5 multiplied by tan, 55.8 degrees. I should put a little bubble there for degrees. Now, I can't type this in my calculator yet because I'm going to be using the tan button. And if you guys remember, anytime I hit any of these 3 buttons, the mode matters. So I'm going to go back to the mode button. And if we are dealing with a problem that has triangles and has degrees, then I have to make sure that my calculator is in degrees. And if I look at my calculator right now, because we cleared the memory, the calculator is in its default mode, which is radians. Default is radians. So we're going to go down to radians, go over to degrees so that it's blinking on degrees, and we're going to press enter, and that puts the calculator into degrees. Okay, now to get there, we hit the mode button right by the blue button, and then we press down and over to where it was blinking on degrees, and we pressed enter. And now to get out of that and get back to the calculating screen, we hit second quit. Second quit. Now we're back to the regular screen. Oh, probably. Clear? Yep, clear does it too. Okay, so now we're going to type 5 times tan, 55.8. And notice when you hit tan is like, yes, tan, what angle would you like me to do? Because you don't just do tan of nothing. You don't just do sine of nothing. You don't just do cos of nothing. You always do cos or sine or tan of an angle. You have a what? Did you type it exactly like this? You have to do 55.8. You can press clear, or you can press second quit. You want to bring up your calculator? It's because you haven't typed in the angle yet. So we're going to do 5 times tan, 55.8. There's your angle. So 5 times tan of the angle. All right. Everyone getting the answer? Yes? Okay. So the side length that we just got is, and it says round to the nearest thousandth. How many decimals is that? 3, yep. So tenth, hundredth, thousandth is 3 decimal places. So 7.357. Did you convert your calculator into degrees?
I didn't put 5,000.
Oh, okay. All right, we all got that? Yes. Okay, let's try the next one. So here is our angle. What is the name of the x side? Adjacent. Okay. What is the name of the 10.3 side? Hypotenuse. Okay. And what trig function uses adjacent and hypotenuse? Cosine. Ka. Yeah, so ka toa. All right, so cos of 51 degrees equals adjacent over hypotenuse. And then how do we get the x alone? Multiply by 10.3. Multiply by 10.3. Those cancel. So the missing side is 10.3 times cos of 51 degrees. And so in our calculator, we're going to type 10.3 times cos 51 degrees. Mm-hmm. 6.482. Okay.
Yeah. Friday.
Probably, most likely. Every so often you'll get one that's a nice whole number, but generally not. All right, here's the next one. What is the 8 side called? Opposite. What is the x side called? Hypotenuse. Okay, so what trig function are we using? Close. And how do we pronounce it? Sine, right? Because it's S-I-N-E, so sine. Okay, so sine of 40 degrees is 8 over x, perfect. Now this one's a little bit trickier because we have the x on the bottom. So what I like to do whenever we have the x on the bottom is I like to put sine 40, I like to put this over 1 because students are really good at doing equations where it's a fraction equals a fraction. Does anyone remember from middle school how to solve these? Cross multiply, yeah, cross multiply. Yeah. So we've got 1 times 8, which is 8. 8 equals x times sine 40. And then what should I do to get the x all alone? Yeah, divide by sine 40. So since the x was being multiplied by sine 40, that's why I'm dividing. And so in my calculator, I'm going to type 8 divided by sine 40. You can type it in as a fraction if you want, because your calculator does that, but you don't have to. You could also type it in as division, and it will give you the same answer. So you can type it in as 8 divided by sine 40. You can type it in like that. Or you can type it in as a fraction and do 8 over sine 40. Both will give you the same answer. So what are we getting? 12.44. Yeah, and the 5 is followed by a 7, so we're going to put 6. So x is approximately 12.446. Okay, and then let's do this last one. What is the x side called? Adjacent. What is the 11 side called? Opposite, okay. And then which trig function are we using? TOA, so we're going to use tan. So tan of 30 degrees equals 11 over x, opposite over adjacent. Okay, we have another situation where the x is on the bottom. So I'm going to put this over 1, and what am I going to do? Cross multiply. So I've got 11 equals x times tangent 30. And then what do I do? Divide by tangent 30. Okay, and it's ready to plug into the calculator. We can do 11 divided by tan 30, or we can type it in like a fraction. We can do fraction with 11 on top, tan 30 on the bottom. 19.053. Perfect. Okay. So if we do problems like this, what is the process? Very first thing we did, what did we start with so that we would know which trig function to use? Yeah, we identified the sides that were given. We didn't write all 3 of them down. We only wrote down the 2 that were labeled. And once we had the 2 that were labeled, we knew exactly which trig function to use. We only had one option. Okay? So then we set up the problem, and then we just had to solve for x. If the x was on the top, it was really easy to solve for. If the x was on the bottom, then we had to use cross multiplication and be a little bit more careful when we solved. Okay, I have a punchline worksheet for you guys today, and it has less problems than yesterday. Isn't that fun? Yes. So it looks like it's got, it looks like it's got 9 problems. Maybe, I guess it's about the same number of problems as yesterday. So we'll start this, we'll see how far we get, and then we'll decide how many problems we should do for homework. So I'm going to go ahead and pass this out.